So a few questions on therapeutic ratio. So a tumor contains 10 to the power of 6 clonogenic cells. Its effective dose response curve has been determined for dose fractions of 2 gray per day, characterized by no shoulder, D naught being 2.5 gray. What is the total dose required to give 37% chance of the tumor control, assuming sufficient time between the fractions to allow full repair of the sublethal damage and no cell proliferation between the doses? So the formula for uh, probability of tumor cure equals e to the power of minus m by into m into SF, where p is the probability of the tumor cure, m is the number of mitotic clonogenic cells, and SF is a surviving fraction. So we need to find and there is also another formula where D10 equals 2.3 into D naught, where the D naught is being given 2.3 into 2.5, which gives us 2.3 into 2.5 equals 5.75. Now with D10 we need to find the number of decades of cell leaving so that we can multiply here and get the total dose. So for that we need to calculate the surviving fraction. So probability over here is 37%, e to the power of minus 10 to the power of 6 into SF. Now ln of 0.37, if you put the e over here, 37 equals minus 10 to the power of 6 into SF. So ln of 0.37 gives us 0.99 minus 0.99 equals minus 10 to the power of 6 into SF. Minus minus gets cancelled. Taking this as 1 divided by 10 to the power of 6 equals SF. So SF equals 10 to the power of minus 6. So we have to multiply this number of decades of cell kill with this. 5.75 into 6 equals 5.75 into 6 equals 34.5. So our answer should be 34.5, which is nearly to 35 over here in E. Now, second question. Based on the same parameters as provided in the previous question, what additional dose must be added to still achieve 37% of the tumor cure if the clonogens in the tumor went 3 cell divisions during the treatment, assuming that there is no cell loss? Now we have the probability is still 37%, but there is additional 3 cell divisions that has happened. So the cells which are there, the number of cells will increase by 3 cell divisions. So m equals here 10 to the power of 6 was the initial number of cells. Now it has doubled once, twice and thrice. So it has undergone 3 cell divisions. So 8 into 10 to the power of 6. So again putting in the same formula, P equals e to the power of minus m into SF. We need to find the SF first. So 0.37 equals e to the power of minus 8 into 10 to the power of 6 into SF. As we know, put the ln over here. Ln of 0.37 will again be minus 0.99, which is around minus 1, equals minus 8 into 10 to the power of 6 into SF. Minus minus gets cancelled. SF is equal to 1 divided by 8 into 10 to the power of 6. 1 divided by 8 gives us 0.125. 0.125 into 10 to the power of 6. Now if you just put the point over here, it will be 1.25 into 10 to the power of minus 6. This one is minus 7. So the decades of cell kill is 7. So we have to multiply again the D10 with 7. So that is 5.75 into 7, which gives us 5.75 into 7, which gives us 40.20. Now they are asking the additional dose, so we have to minus the earlier dose, that is 34.5, which gives us 34.5, which gives us 5.75, which is nearly 5 over here. So the additional dose required is 5. Okay. Now the next question: suppose a chemotherapeutic agent that kill the tumor cells independently of radiation was also employed during the aforementioned course of the treatment. It is known from the previous data that this drug regimen results in surviving fraction of 10 to the power of minus 4 under treatment. Now, what is the total radiation dose required to produce 37% of chance of tumor cure, assuming that the 10 to the power of cells go through those extra 3 cell divisions? Now, due to this chemotherapy, what is happening? Just suppose it is killing the tumor cells, so the radiation required will be lesser. So we need to find the factor by which the radiation has to be minused. Okay, so this is assuming, okay, 1 second. So again, SF is being given here 10 to the power of minus 4, so we will multiply again d naught into 4, that is d10 into 4, that is d10 is 5.75 into 4, that gives us 5.75 into 4, 5.75 into 4 gives us 23 gray. Okay, now we initially know that 34.5 gray was required initially from the first question, and then from the second question we got to know that it was 5.75 gray that was required extra. Totally it was 40 point something gray. Now we have to minus 23 for this. So 34.5 plus 5.75 minus 23, it gives us 17.25. So the dose over here is 17.25.